stuff. It's all stuff you've seen before. None of it is new. You did all of this last year. These are logarithmic functions. A logarithm is a crazy fancy word that's talking about the inverse of an exponent. Let's say, and don't write this down, but let's say I have x plus 4 equals 10. How am I going to solve for x? Subtract 4 from both sides, because subtraction is the inverse operation of addition. Logarithms are the inverse operation for exponents.
What is that?
Right here. Here you go. What did we do?
Hey guys.
Oh, Britton didn't pass it down. Now, normally, you guys, we do some explanation and then we jump into some problems. I think we're just going to jump straight into the problems and you'll kind of be refreshed as we go. Okay? On number 1, it says write each equation in exponential form. You're not solving anything. You're just rewriting it in a different form. Now, what I'm about to say out loud, some of you might think is a little bit elementary, but I think it will help you remember. There we go. People have been like shoving it back. I don't know why. Okay, here we go. So number 1, again, I realize this is a little bit elementary, but it'll help you remember. The base of the log is always the base of the exponent. So here we go. When I pick up this base, the log falls off, and then I take that base and I throw it across this river. And it bumps into the 4. And it bumps the 4 out of the way. The 81 is untouched. Is that a true statement? Is 81 3 to the 4th power?
No. Let's see.
Yes, it is.
3 to the 4th.
So I know I did it correctly. That's the answer. That's it. That's all you had to do was rearrange it in exponential form. Let's look at number 2. When I pick up the base, it knocks the log off. I toss it across the river and it bumps into the 1/3. It scoots him out of the way. 2 equals 8 to the 1/3 power. 8 to the 1/3 is the cube root. The cube root of 8 is 2. True statement. Any questions on 1 or 2? Thank you. You guys do number 3. Did you guys get what I got? Is it a true statement?
Yes.
Yeah. We're good. Questions on 1, 2, and 3? All right, let's look at 4, 5, and 6. They're giving us the exponential form. We have to give it back in the logarithm. Now remember I said that the base of the exponent is the base of the log. So log base 3, that's where that comes from. I'm going to draw an arrow because these are my notes. I want to make sure I remember. And then the other 2 guys, just swap places. And that's it. So the base of the exponent becomes the base of the log. Let's do number 5. So it's log base what? 5. What do I do with the other 2 guys? Trade places. You guys do number 6. When you finish, look up. Our answers should match. Any questions on 1 through 6? Awesome. Number 7. It says evaluate each expression. That means simplify it or break it down or find an answer, basically. Now, number 7, they gave that one to you first, but it's a property you probably forgot. If you have a log base of a number, and you've got that same number raised to a power, you can cross these 2 out, and the answer is 3. It's just a little rule. You might put a star by it so you don't forget. Number 8. All right. They want us to find this answer. We don't know what it is. So we're going to say equals x. We don't know what it equals. That's your first step. Second step, pick up your base, throw it across the river. And write small because this is several steps for this one. They're not always very long, but this one is a little bit. Okay, now please hear me. Because you'll get to this on your assignment and you're going to go, I don't really know how to do this one. You do. Every time you have a decimal like that, every time, write it like a fraction, and you'll be able to get your answer. How do you guys say that out loud? 1/1,000. So isn't this also 1/1,000? Okay, so write that down. So all we've done is we've changed the form. Now your goal is to get the bases on each side to match. This base has a base of 10, or this exponent has a base of 10. 1,000. Can I turn that into a base of 10?
Yes.
10 to the what? 10.
Third or
Yep, third.
third.
Okay, we're getting closer. If the exponent is on the bottom, can't I bring it to the top and make it a negative?
Yeah.
So if 10 to the negative third equals 10 to the x, is it negative 3x? Yeah, they would have to be. If they're equal to each other, then they've got to have the same exponent. So negative 3 equals x. Now we're going to do several more so that this one will feel a little bit more natural to you. But does anybody have any questions about how I got from one step to the next? Does everybody see the progression? Okay, you'll be able to do it by yourself here pretty soon, I promise. Number 9. I don't know the answer, so I say equals x. What do you think the next step is?
Throw your log off and throw it across the river.
Good. Throw the 8 across the river. So we have 4,096 equals 8 to the x. Now on your quiz on Tuesday, you will not be able to use a calculator.
Oh, come on.
You'll have a root chart, and so I will promise you I will not give you something this large that you can't do without a root chart. Okay, everything I give you, you'll be able to do by looking at the root chart. So, but for right now, I'm going to grab my calculator and just kind of show you. If I do 8 to the 4th, I get 4,096.
Wait, we can't use our calculator for those equations either.
For these equations?
For those.
For those? Well, I may do it in 2 parts, or I may write the quiz in such a way that you won't need a calculator, even for those. Okay? We're going to change 4,096. We're going to rewrite it as 8 to the 4th, because 8 to the 4th is 4,096. So what's x?
4 equals x.
4. Questions on 9?
Does it matter if you put x equals 4 or equals x? Or...
No, but because the x is on the right, I just left it on the right. Number 10, what's your first step? Whoops, I don't have a river. Thank you. Equals x. Now throw your log or your base across the river. Thank you. All these kids that are gone today and they come Monday and they talk about throwing things across the river, they're going to be going, what? They'll have to watch the video. Because I don't know of any other teacher that says this. I sort of made it up. Okay, we want our bases to match. The problem is 4 to the anything we're aware of is not 32. But can't I rewrite 4 as 2 squared? Because 2 squared is 4, so I could just rewrite it. 32 is 2 to the what? Do you know? Good, 5th. I heard it. So I have 2 to the 5th equals, what happens when I have a power to another power?
You multiply.
You multiply them. So I have 2 to the 2x. So what do you think I write next?
5 equals 2x.
Good. Set the exponents equal to each other. Divide both sides by 2. And we get 5/2. And if you wanted to check it in a calculator on your assignment or something, you could say, okay, 4 to the 5/2 equals, and you get 32.
Can't use a calculator.
I said on your assignment. On your assignment to double check. Okay. Number 11. You guys try that one by yourself. Does this one feel kind of tricky?
Yes. No. Yes.
What's the only way to do an exponent and get a 1? What would the exponent have to be?
0.
There you go. X is 0. It's the only way you're going to get the answer of 1 is if the exponent was a 0. Alright, you guys try 12. How'd you guys do on 12? Did you pretty much do that by yourself? Is everybody okay? Awesome. 13. Solve each equation. What do you want to do?
Go over the river.
Okay, let's try it. 64 equals x to the 3rd power. How am I going to get x by itself?
Square root. Or cube root.
Cube root. There you go. Cube root of both sides. And that's it. Now, something you need to know, and I would write this kind of alongside the left-hand side of your worksheet over here. If I have log of log base x of y, I'm just using those in place of, whoops, sorry. I'm just using those in place of numbers right now. The x and the y, whatever those numbers are, must be positive. Or it's undefined. You can't have a log base that's negative, and you can't have a log of something that's negative. Questions? Okay, so when I look at this, if x is 4, is that possible? Yeah, it's fine. Let's look at 14. What do you want to do? Okay. What do you guys want to do next?
We gotta make
Yeah, I heard it. You got to make a decimal a fraction. Now when you get this far, it's kind of up to you. Some of you can tell really quickly that it's easy to make both bases, just leave them as 4s, but some of you are going to want to break it down all the way to 2s, and that's fine. Either way, you get the same answer. 1/4, isn't that the same thing as 4 to the negative 1?
Oh, yes.
You know what I'm saying? So then negative 1 would equal x. Is it okay if that x is a negative?
X can't be negative.
If it's over here, can it?
Yes.
Sure, why not? That one's fine. All right, 15. Oh, we have some rules here. Here's the thing. If you've got log base of blah equals log base, the same base, equals another blah, doesn't this have to equal this?
Yeah.
Can't we just drop the logs? Sure. Drop the logs.
Drop.
So we have. Oh, I did not think of that. Nobody laughed first and second hour. You guys are bad. 2x minus 1 equals 16. Oh, I'm gonna have to do a new video now.
No. Keep that.
Leave it in there. Parents will love that. 2x minus 1 equals 16. What do you do next?
Add 1.
Okay. So 2x equals 17. Divide by 2. Just leave it as 17 halves. It's fine. Now, if I take 17 halves and I put it in here, I have to make sure that doesn't make that negative. And it doesn't. It makes it 16, so we're good. It works. There are extraneous solutions on logarithms. So you have fake answers sometimes. 16, what do you want to do?
Square root off there. Oh, no. Wait.
That's for the x, right?
You throw it across the river.
You have to throw it across the river first. You have to pick up your base and get rid of your log first. You know, in all my years of teaching, I don't think any class has ever said that or noticed that.
You got a bunch of lame kids.
I guess so, because I've said that every year. Okay, I'm going to be really self-conscious about that now.
If anybody else gets
What can we do to get both of these to have a base of 10?
square the left side, square the other side. No?
Isn't radical 10, can't we do inside over outside? Isn't that 10 to the 1/2?
Oh,
Oh, now we see it.
that thing that we did like 2 days ago.
Yep. Okay, before we go on, you need to write some rules at the top of your paper. You should know these, but just in case you don't remember them, I will write them for you. One of the rules says that if I have log base, we'll call it b, of, let's say, m times n. Those are all numbers. It's the same thing as log base b of m plus log base b of n. And that kind of makes sense. If these are like inverses of exponents, your rules for exponents say that if you're multiplying and the bases match, you add the exponents. So here we see multiplication and addition together again. That makes sense. So if I have log base b of m divided by n, I could have log base b of m minus log base b of n. They mean the same thing. You can exchange one for the other. It's the exact same thing. Also, you may have forgotten this. If you have log base b of a number to another number, like a power, it's the same thing as taking that power, catapulting it over the log, so that you have n times log base b of m. Those mean the same thing. Well, I use those words so that you'll remember. Last rule. What was the rule? Oh yeah, I remember. Log base b of m, if it equals log base b of n, and we just used this one actually, then I don't even know how to say this without saying drop the logs. You just lose the logs? I don't know, like
Drop logs.
Let
river.
logs fall.
the logs go away, and so you have m equals n.
Be proud about dropping off.
I'm so self-conscious
Just
about
say
that
it,
now.
just say it.
I'm not going to say that every time.
You have to. See if your other classes notice.
Okay, I'll try next time. We'll see if they. So on number 17, now here's the thing. And try not to get lost in the joke whenever I say this. A lot of kids, if they make a mistake on this, it's always the same mistake. They're going to look at this and they're going to go, oh, I can just drop the logs. I know, giggle, giggle. But you cannot lose those logs. Because stop. I'm really gonna have to do another video.
Don't do it.
What you have to do, guys, is you have to condense that down to one logarithm before you can cancel the logs out. Look how well I did that.
It's dropped.
So we have log base 7. Now that's subtraction, so what do I do with those guys? Divide. So I have 56 over x equals log base 7, 4. Now that I have one logarithm equal to another logarithm, and both of the bases match, yeah, you cross them out. Thank you.
Drop.
And solve just like you did in 9th grade. Questions on 17? You guys try 18. Try to do it by yourself, but if you need to sneak a peek, I get it. Oops.
Why do you have to make it minus 12?
It's a quadratic equation, so you have to set everything equal to 0. Factor, and then you get your answers. Now don't put a box around those.
So why do we have to
Do what, Riley?
pick the logarithm?
You have to get it down to just one log on each side. Then you cross out your logs, and then you multiply those together, and it's a quadratic, so you have to set it equal to 0. Now, problem, if I have -6 and I plug it in here, that's going to say log base 5 of -2. Can you do that?
No.
No, so we have an extraneous solution.
So you can only have 2 logs on each side of the equal sign to cancel it? You can't have more than 2?
You can only have one on each side. To cancel it, you can only have one on each side.
Okay.
Yeah. All right, number 19. Now, this is where sort of your new formula comes into play. Half-life. You've seen this before. You've done this before. Here's what it is. You have to know this for your quiz on Tuesday. And I will tell you, little hint, and I don't remember what number it is, but on your assignment, there's one word problem where it talks about the bacteria or something is multiplying. The cells, I think, are multiplying or something. So instead of having a half raised to the power of t, it's 2. So just make yourself a little note. You might have to use this. You will have to use this, actually, on one of your problems when it's doubling. Half-life is much more common, though, to have to use that. Okay, again, just like always, n is your final amount, n sub 0, that's your initial amount. You've got a half t. This time is not time. It says that it represents the number of half-lives. So let's see here. How long would it take 100,000 grams of radioactive iodine? So already I know where to put 100,000. Where do I put it? Is it the final amount, or is that what we're starting with?
So we're starting with.
So we're starting with. So I'm going to have equals 100,000. How long would it take that iodine, which has a half-life, by the way, of 60 days? We're going to tuck that away for later. We'll need it in a minute. To decay to only 25,000 grams. So there's our final amount. Times 1/2 to the power of t. And then the rest is just explaining what all of the letters stand for. So to solve for t and get it by itself, let's divide both sides by 100,000. 25,000 divided by 100,000 is a fourth. So if 1/4 equals 1/2 raised to the power of t, let's get the bases to match just like we did on the top part. On the right, 1/2, isn't that the same thing as 2 to the negative 1? Yes?
Yeah.
So on the left, what's 1/4 equal to?
4 to the negative 1.
4 to the negative 1, but is that going to help us get our bases to match?
No.
Can we get a base of 2?
Yes.
2 to the, how about negative 2? Right, because it's on the bottom, Blake?
Yeah.
So now I have 2 to the negative 2 equals 2 to the negative t, because power to a power, you multiply. So negative 2 equals negative t, 2 equals t. But that's not your answer. That's how many half-lives it took to break down that iodine. Each half-life is 60 days. Every 60 days, you cut it in half. So we have 2 half-lives times the 60 days. So we have 120 days. That's how long it took. So don't forget that last step because you'll get the answer wrong. T is not time in this formula. Questions? Okay, let me hit stop on this. Just